Hello, welcome to Physics Lab 1, the constant velocity lab. So the purpose of this lab is observing the motion of an object moving at the same speed without changing direction. And some models and fundamentals that we need to understand is I did this experiment using Tracker, GlowScript, and Excel. So Tracker is a motion capture system which tracks how fast an object is moving by seeing the position over a set amount of time. GlowScript is the computational way to see our velocity, and then we use Excel to compare the tracker and GlowScript data. So Newton's second law and position update and formula are important to this experiment, and so is the free body diagram, because the free body diagram explains the force on the object. So Newton's second law, the net force equation turns into the position update formula and then turns into the velocity update formula. And since we assume that the object is moving at the same speed, the net force on the object should be 0, and the initial velocity should be the same as the final velocity. So this is the video of the tracker software. And as you can see, each of those individual tick marks, are the red marks, are the spots that I individually put, and this helps track how fast this expo marker is moving over a set amount of time. And this is the data I got from that tracker software. It plots the time and the position, also the y, but in this case the y is not important. And this is a blown up picture of my data for this tracker software. As you can see, the time starts at 2 seconds and 30 milliseconds, or 2.3 seconds. And this is my GlowScript code. So this is the code I use to get my information for my experiment, or for my computational data. The things I've underlined is what I've changed to get my values. And for the first underline, the 0.79, I calculated that by taking the change in position and the change in time through the tracker software and divided by each other to get a velocity of 0.79. And my average change in time on the tracker was 0.033, as you can see as my delta t. And so I ran this code and I got some values, and the data table on the right are the values that I received from the code, and the data table on the left is what I got from the tracker software. And then I put both of these data points into an Excel sheet where I got a time position curve, and the orange one is the computational data and the blue line is the experimental data from the tracker software. As you can see that these slopes are very similar, indicating that these were at the same speed, even though the point of origin for these graphs are not the same. They are still going at the same speed. The reason that these aren't at the same origin is because on the tracker software it calculated that the first point started at 2.3 seconds, while the GlowScript code calculated the first point at 0 seconds. And so this leads to, what if the axis were flipped? If the object was rolling in the opposite direction, negative x instead of positive x, the slope of the graph would still be the same, just in a negative form. The positive and negative x values for the graph would also have the same y value. And so what does this mean? Is it possible to say how many pushes or pulls are on an object to get a net force of 0? And I would say it is not possible, as everything has a gravitational force, thus everything in the surrounding is contributing toward the objects. So if there's infinite number of forces on this object, you wouldn't be able to find out how many forces are on this object.